So today we're going to be talking about changing motion, which is essentially still part of kinematics, but we're going to add in another variable, acceleration. Acceleration is basically the change in velocity of the change in time, as opposed to in constant motion where our velocities remain constant. Now we're going to have a change in velocity which leads to acceleration. So there are four basic equations that we're going to use in this unit, the first of which is the displacement equals the average velocity times the time, which is one that we used last unit. Second one is the final velocity equals the initial velocity plus acceleration times time. The third one is the displacement equals the initial velocity times time plus 1/2 of the acceleration times time squared. And the final one is that the final velocity squared equals the initial velocity squared plus 2 times the acceleration times displacement. So question 1. Calculate the displacement of a plane that uniformly accelerated from 66 meters per second to 88 meters per second in 12 seconds.
The first step in this is to list out our givens. So we know that our initial velocity is 66 meters per second. Our final velocity is 88 meters per second. Our time is 12 seconds, and the distance is unknown. Okay, so to figure out an equation that connects these variables, well, we know that the distance traveled equals the average velocity times the time. Because we have a constant acceleration, we can average our initial and final velocities to figure out our average velocity. So this would be the same thing as the initial velocity plus the final velocity divided by 2 times the time should give us our displacement. So now we're going to plug in our values that we have. So the change in displacement equals the initial velocity of 66, so the final velocity of 88, divided by 2 times the time of 12 seconds. And if we put this into your calculator, you would get a distance of 924 meters.
Question 2. Calculate the distance of runner, whose velocity time graph is shown below, travels in 16 seconds.
Okay, so for this one you have to realize that if you have a velocity with its time graph, the area under your curve is going to be your total displacement. So using that idea to find the displacement, we're going to get the area under this curve by splitting this entire shape into different things that we can actually calculate the area of. So we can make a triangle here, can make rectangle, triangle, and another rectangle. And so the area of this here would be 8, 64, the area of this would be 4, and the area of this would be 24. And if you were to add all those up, the 8 plus 64 plus 4 plus 24, we would get 100 meters as your displacement.
Question 3. A bumblebee has an initial velocity of 3 meters per second. Part A. The bee accelerates at the rate of 0.5 meters per second squared for 7 seconds. Calculate the bee's final velocity.
Okay, for this one, we know that the initial velocity is 3 meters per second. The acceleration is 0.05 meters per second squared. The time is 7 seconds, and the final velocity is what is unknown. That's what we're solving for. The equation that relates these four variables is final velocity equals initial velocity plus acceleration times time. If we plug in our values for this, final velocity is going to equal 3 plus the acceleration of 0.05 times 7 seconds. Your final velocity is going to be 6.5 meters per second.
Part B. Now if the bee accelerates at the rate of negative 0.6 meters per second squared, how much time will it take to reach a complete stop?
So this one again, our initial velocity is going to be 3 meters per second. However, our acceleration now is going to be negative 0.6 meters per second squared. And because we're trying to figure out when it stops, we know the final velocity is going to be 0. We're trying to solve for the time. So again, the equation that relates these four variables is final velocity is the initial velocity plus acceleration times time. However, we have to manipulate this equation so that we can solve for time. So the velocity final minus velocity initial is going to be acceleration times time. Divide both sides by acceleration, so final velocity minus initial velocity divided by acceleration d time. Now we're going to plug in all of our variables. Final velocity we established was 0, minus initial velocity of 3, divided by negative 0.6 gives you time. And thus the time is 5 seconds.
Question 4. A ball initially at rest rolls down a hill with a constant acceleration of 3.3 meters per second squared for 7.5 seconds. Calculate the distance the ball travels.
This one, we know that the ball is initially at rest, so the initial velocity is 0. The acceleration is 3.3 meters per second squared. The time is 7.5 seconds. Try to solve for distance. The equation that relates these is the displacement or distance equals initial velocity times time plus 1/2 at squared. Because we know initial velocity is 0, this cancels out. And so now we plug in our values. Distance equals 1/2 acceleration times time squared, which gives us distance of 92.81 meters.
Question 5. An object with an initial velocity of 5 meters per second has a constant acceleration of 2 meters per second squared. When its velocity is 15 meters per second, calculate the distance it travels.
Okay, for this one we know that our initial velocity is 5 meters per second. Our acceleration is 2 meters per second squared, and our final velocity is 15 meters per second. Trying to solve for distance. The equation that relates these is going to be final velocity squared equals initial velocity squared plus 2 times acceleration times distance, and we're trying to solve for this. So we have to manipulate our equation so that we have it equaling to distance. And then we're going to plug in our values, so 15 squared minus 5 squared over 2 times 2, which is going to give us 50 meters.
At 5 seconds, an object is at 3 meters and traveling at 5 meters per second. At 8 seconds, it is at 9 meters and its velocity is negative 1 meters per second. Calculate the acceleration for this interval.
So there are different ways of solving this problem, but I'm going to do the one I think is the easiest. So what we're given is we know that time 1 is 5 seconds. We know time 2 is 8 seconds, which gives an overall change in time of 3 seconds. We know the distance 1 is 3 meters. Distance 2 is 9 meters. And then we know velocity initial is 5 meters per second, and velocity final is negative 1 meters per second. So there are different equations, again, that you can relate these to, but I like using that velocity final is velocity initial plus acceleration times time. Remember, we're trying to solve for acceleration, so this is kind of irrelevant in the way we're solving it. So we're going to, again, solve for acceleration, so velocity final minus velocity initial divided by the time. It's going to give you acceleration. So plug in values, negative 1 minus 5 over the time of 3. It's going to give us acceleration of negative 2 meters per second squared.
Question 7. 2 cars travel westward along a straight highway, one at a constant velocity of 85 kilometers an hour, and the other at a constant velocity of 115 kilometers an hour. And then part A asks, assuming both cars start at the same point, how much sooner does a faster car arrive at a destination 16 kilometers away?
Okay, for this one we know that the velocity for car 1 is 85 kilometers an hour. We know that the velocity for car 2 is 115 kilometers an hour. And then the distance for both of them is 16 kilometers. And we don't know time 1 or we don't know time 2. So traveling at a constant velocity, so the equation we use is distance equals velocity times time. And we're going to try to get the difference. So first we're solving for time, so time is distance over velocity, and we're trying to get the difference between the two. So what we're going to do is we're going to do distance minus velocity of 1 minus over velocity of 2 is going to give us the difference in time between the two cars. So now plug in our values, so 16 over 85 minus 16 over 115 is going to change in time, which is going to give us 0.049 hours. And the answer gives it in seconds, so we're going to multiply this by 3,600 to give us 176.78 seconds.
Then part B asks, calculate the distance the cars must travel for the faster car to arrive 15 minutes before the slower car.
This one again, I know the velocity of car 1 is going to be 85 kilometers an hour, and the velocity of car 2 is going to be 115 kilometers an hour. And this one, our distances, which are unknown, are equal though, and it's unknown, and then we know that time 1 minus 0.25 is going to give us time 2. The reason why we use 0.25 is because it says 15 minutes, and so because our question gives it in hours, we have to convert this to hours. And because velocity 1 is slower, this time is going to naturally be bigger. So that's why it's minus, to get that. Okay, so again, we're dealing with constant velocity, so the equation we're going to be using is distance equals velocity times time. And we know that two distances are equal, so we're going to set up our equation. Like velocity 1 times time 1 is going to give us velocity 2 times the time 2, which is time 1 minus 0.25. And now, so the first step we're going to do is solve for time 2 in order to eventually solve for the distance. So now we're going to use some algebra. V1 T1 is V2 T1, and distribute that out. Bring your T1s onto one side, so V2 1 minus V1 T1 is going to give us 0.252. So the time of car 1 is going to be this, and if we plug in our values, 5 is 115 over 115 minus 85, which is going to give us a time of 0.9583 hours. And so if using that idea, if distance equals velocity times time, and we're going to use time 1 and velocity 1, so the distance is going to give us 85, the velocity, times the time, which is going to give us a distance of 81.46 kilometers.
Question 8. A speeder passes a parked police car at a constant velocity of 30 meters per second. The police car starts from rest with a uniform acceleration of 2.4 meters per second squared. Part A. How much time passes before the police car overtakes the speeder?
Because this problem combines both constant and changing velocity. The speeder has constant velocity, and what we know about the speeder is that its velocity speeder is 30 meters per second. And then for the police car, we know that this one's the changing, so its initial velocity is going to be 0, and we know that it's accelerating at 2.44 meters per second squared. We know that when they overtake, or both of our times are going to be equal, and the distances are also going to be equal. And what we're trying to solve for is this time. Okay, so now we're going to figure out what equations we need to use. So for the constant motion, always we're going to use distance equals velocity times time. And then for the changing motion, using the equations, the variables that we have, we're going to use the distance equals the velocity initial times time plus 1/2 at squared. And so we established that our distances are the same, so we can set both of these equal to each other. So the velocity of the speeder times time is going to give us the velocity initial of the police plus 1/2 acceleration of the police times time squared. We know that this initial velocity is 0, so we can just cross that out. And now I have to solve for the time. So to isolate the time, we would end up getting the time as being 2 times the velocity of the speeder divided by the acceleration. We plug in our values, we would get 2 times 30 divided by 2.44, which would give us 24.59 seconds.
Part B. Calculate the distance a speeder travels before being overtaken by the police car.
Just remember again, the speeder is traveling at a constant velocity of 30 meters per second, and we established in the previous question that the time was 24.59 seconds, and we're trying to solve for the distance. So constant motion, our equation is equal to velocity times time. Distance is going to be 30 times 24.59, and our distance is going to be 737.7 meters.
A red train traveling at 72 kilometers an hour and a green train traveling at 145 kilometers an hour are headed toward one another along a straight level track. When they are 950 meters apart, each engineer sees the other's train and applies the brakes. The brakes decelerate each train at a rate of 2 meters per second squared. Is there a collision? If so, calculate the speed of each train at impact. If not, calculate the separation between the trains when they stop.
So this one we know the red train is traveling at 72 kilometers an hour, and the green train is traveling at 144 kilometers an hour, and this is both of their initial velocities. And then we know that the acceleration is -2 meters per second squared. Now this, because it's in meters per second and this is in kilometers per hour, we have to convert. So if we divide both of these by 3.6, we can get both of them in meters per second. So we're going to get 20 meters per second for the red and 40 meters per second for the green. And what we're solving for now, what we're going to assume is that these trains stop. So we're going to set the final velocity for both at 0 meters per second. And we don't know the distance, and that's kind of what we're trying to solve for, us to see if they clash or not. And we know that the distance they're apart is 950 meters, and that's something that we'll use later. Okay, so the equation connecting these variables, we're going to use the velocity final squared is equal to the initial velocity squared plus 2 times the acceleration times the distance. And we're going to do this for both of them. So if we, just looking at this, if we're going to solve for the distance, we would get final velocity squared minus initial velocity squared divided by 2 times the acceleration is going to give us the distance. Okay, so for solving for the red, what we're going to do is the initial velocity is 0, the final velocity is 0 minus the initial velocity of 20 squared divided by 2 times the acceleration is going to give us 100 meters for the red train. Same thing for here, distance equals 0 minus 40 squared divided by 2, -2. So we're going to get a distance of 400 meters. So this basically means that the red train travels 100 meters before it stops, and the green train travels 400 meters before it stops. So if we have the red train here, and the green train here, and they were 950 meters apart, this one travels 100 meters and stops, this one travels 400 meters and stops. Obviously they're not going to clash because these two are added together is less than that. But how far they're going to be apart? Well, if the total is 950 and this is 100, this is 400, we're going to do the 950 minus 100 minus 400, which is going to give us 450 meters apart.
I really hope this video helped, and thanks for watching!